Hi guys, good morning. So in the last session, we have seen about the clustering concept, that how you can combine two firewalls and they will start behaving like a single firewall. Okay. Now, today we'll go with the transparent firewall concept. So what is this transparent firewall concept? So normally what happens, your firewall has two modes. Okay. One is the routed mode and second is the transparent. Okay. So in routed mode, your firewall act as a L3. Okay. While in the transparent mode, it will be behaving like a L2 device. Okay. That means your transparent firewall you can consider like a switch with the firewall capabilities. This is what you can generally say about a transparent firewall. So like, a switch cannot act as a gateway. So same thing here, cannot be used as a edge device. Okay, you cannot use your transparent firewall as a gateway. While L3 can be used as a edge device. Okay. So now why do you require this transparent firewall concept? Okay, why would you deploy the firewall in the transparent mode? So let's consider that your organization has a edge router that is connected to the internet. Okay. And this router is responsible for handling, all the VPN connection and everything. That means everything is configured here on the router. And this is your router. Then you have a switch which is connected to the router. And then with this switch, you have connected hosts. Okay. And this is a host that is connected. Let's say this is your PC1, or you can consider your inside PC. This is your router. This is your switch. Okay. This is, let's say, Z0 by 0 interface. And this is Z0 by 1 interface. Okay. Now, this is your internet. And then this one you can consider your, again, Z0 by 0. On this side you have Z0 by 1. Okay. The IP address on the PC, let's say 10.1.1.5. And the MAC address, just consider here M1. IP address on the router on the inside 10.1.1.10. And on the outside 11.1.1.10. Here MAC address, let's say M2. Here, let's say MAC address H. Okay. So this is your network, and right now it is working very smoothly. Okay. There is no issues. But according to default behavior of firewall, according to default behavior of your router, whenever somebody will try to access from outside to inside, so as per default behavior, your router will allow the communication until or unless it is blocked with an ACL. Okay. So your router will allow it, the communication. And if you want that, okay, I need a firewall. Okay, I need a firewall to monitor my incoming and outgoing traffic. But the thing is, I cannot afford to bring down my network. Okay, I can bring down my network. Okay, my network cannot go down. So this is the router. The setup is going to remain as it is, but still I want to add a firewall in my network. Okay. So in this case, what you will do, you will use the transparent mode, because if you want to use your firewall in the routed mode, then you will have to remove this router, correct? If you want to use your firewall in place of your router, then you have to remove it. And in place of this, you will have to put a ASA. So for that reason, you have to bring down your network. Okay. Another way, in the transparent mode also, you can deploy the firewall, not a problem. Okay. So like one way to deploy the firewall in the transparent mode is what? That, let's see. Same, but I will try to deploy here a firewall in the transparent mode. So let's say this is your ASA that you deploy in the transparent mode. And this is how you can use it. So this is one of the scenario how you can use a firewall in the transparent mode. So consider this is your ASA. Okay. And it is in the transparent mode. But again, here also there is a problem, right? That if you deploy like this, still you have to bring down the network because this cable has to be removed. Then you will connect your ASA in between your switch and your router, and then you have to configure the ASA with all the policies and everything. So again, this is also not a good solution if you want to deploy in the transparent mode. Okay, so what is the best way to deploy the firewall in the transparent mode? The best way will be, this is what, let's say this is your traditional network. Okay, where without firewall. Here we haven't used a firewall. This is network with firewall in transparent mode. And this is what? This is scenario one. And this is not recommended. Because here also, you have to bring down your network. Okay. So like I said, what would be the best way? So the best way would be network with firewall in the transparent mode. And this one, right now we are talking about your scenario two. Okay, and this one is the recommended one. So whenever you study, about your transparent firewall concept right now in ASA and later on in FTD, so you will go through the same scenario. This is the one that you will be deploying your firewalls in. So like this is your traditional network. Now here, what you want to do, you want to deploy your firewall. So you will deploy your firewall here. Okay. Like this is your ASA and it is in the transparent view. Okay. Now the interfaces G0 by 0. And this is Z0 by 1. Okay. Now, and if we talk about the switch interfaces, so the switch interfaces will be Z0 by 2. And here it will be Z0 by 3. Okay. But now what will happen if we talk about the gateway IP address in your PC? So the gateway IP address in your PC is going to be 10.1.1.10. Okay. So that means your PC will start forwarding the traffic directly to the router. That is the normal scenario without the firewall also if you consider. So like the switch will be responsible for forwarding the packets, whether it has to forward to the whether it has to forward to the ASA or the router. So that will completely depend on how the CAM table of your switch is populated. So in the normal scenario, when you don't have the firewall, how the CAM table will be? If we talk about your switch CAM table, so see how it will look like. Switch CAM table. I believe everyone is aware about CAM table, right? Okay, great. So now, if we talk about the CAM table, how it will be. So like it will have information that what MAC address belongs to which port. Okay, right now I'm not, and there also be information about the. Okay, right now we are just considering these three things only. So how this MAC CAM table will look like in the normal scenario? That M1 MAC address will be learned via port Z0 by 0, and by default it is part of VLAN 1. Okay, M2 will be learned via Z0 by 1, by default part of VLAN 1. This will be the scenario. So what will happen when your PC will generate the packet? It will say destination IP, source port, or source MAC, destination. So source IP will be 10.10. Let's say your PC1 wants to communicate with some internet router. Let's say there's a router here, or another PC or anything you can consider. So here it is having the IP address 11.1.1.25. So it wants to communicate to the 11.125. Source MAC address. So PC1 will know its own MAC address. It will say M1. About destination MAC address. So we all know that after R, your PC1 will be using the gateway MAC address. That means destination MAC address will be M2. And when this packet will come to the switch, which will check what is the destination MAC address, M2. M2 belongs to which port? Z0 by 1. It will forward it here, and later on router will forward it to internet, and the communication will happen same like this. So will my packets go to the ASA? Even if I have deployed ASA, will my packets go to the ASA? Looking at this CAM table? No. Correct? So now I want that these packets, they should go via ASA. So what I can do here, how I can force my traffic to go via ASA? So what I can do is I can divide this, not basically altering the CAM table. We will be creating VLANs. If I create VLAN and if I put your Z0 by 0 and Z0 by 2 in one VLAN and Z0 by 3 and Z0 by 1 in the one VLAN. So that means directly my traffic cannot go from Z0 by 0 to 0 by 1, correct? Directly, my packets cannot go, my frames cannot go from Z0 by 0 to Z0 by 1. So here what we will be doing, we will be creating two VLANs, okay? One VLAN this side, okay? And one VLAN on this side. So let's say this is VLAN 10. And this is VLAN 20. Now, when PC1 will try to communicate, so switch will not know now that how to reach because it is a different VLAN. So that means the ARP will happen, the broadcast will happen, all these things will happen. And the frame will come where? On the ASA. One copy of the frame will come where? On the ASA also. Okay. So now by default, your ASA will not forward the traffic from port Z0 by 0 to Z0 by 1. Because these are two different interfaces. Okay. So what we have to do, we have to bridge these interfaces. Okay. We have to bridge these interfaces. And for that, in the ASA, we have to create a concept that is known as BVI, Bridge Group Virtual Interface. And that will kind of create a bridge between the two interfaces, that whatever the traffic will come on this port will be forwarded to this port. Okay, so this concept is the BVI. We will create what? BVI. Okay. So what is BVI? Known as Bridge Group Virtual Interface. Okay, so this is a virtual interface. And it will be responsible for kind of creating a bridge between the two interfaces. Okay, if you remember, like in your Windows, you have option to bridge two network adapters. So what happens? Automatically, like whenever you want to communicate or want to provide internet from one PC to another PC, so two network adapters are there. On one, you are having an internet, and on second, you are not having. So you can bridge both of them and you will get the internet. These kind of things you can do, yes or no? Are you aware about that? Bridging the network adapters. Or if you have used VirtualBox, how many of you have used VirtualBox? Used. Okay. So let me show you in the VirtualBox. See. So whenever, if you have created some virtual machines in your VirtualBox, then you might have noted that like we have options to attach the network adapter, and we can keep the network adapter, as in a NAT mode, internal host only, NAT network, cloud network. Okay. But we also have an option for bridge adapter. Bridge adapter means it will directly use my physical NICs. That means my physical NIC will get a bridge. A bridge will be created between the virtual network adapter of my virtual machine and my physical NIC. That means directly they will be able to use my physical network. Is it clear? Yes or no? Or is there any doubt? Clear. Okay. So here the bridge, okay, this bridge, what it is responsible for forwarding whatever the traffic arrives on Z0 by 0, forward it to Z0 by 1. Whatever the traffic arrives on Z0 by 1, forward it to Z0 by 0. So one reason for your BVI is what? That it will create a bridge between these two interfaces. Okay, it will bridge these two interfaces so that the traffic can be forwarded in either direction. And second thing, here on the BVI, we will assign IP address. Okay, whatever the IP address we will assign, so we will assign to the BVI. Why? Because if you want to manage your firewall remotely, then you will need to access your firewall. Okay, and you cannot use these physical interfaces to access. Why? Because these are the interfaces which are working like a L2 now. These are not working like a L3. So you cannot assign IP addresses to these interfaces now. Okay, so we will assign IP address to the BVI interface for management of the firewall. Okay, so this is one thing that we will do. Now, once we will create the BVI, what will happen? Once we will create the BVI, what is going to happen? This MAC address. Okay. This MAC address, it will start reflecting here on the Z0 by 0 interface. And the MAC address of your PC1 will start reflecting on the Z0 by 1 interface. Okay. So like here, M2 will be reflected, and here M1 will be reflected. And once you create the BVI, you do the transparent firewall configuration, this CAM table will modify. How it will modify? See. Now, in your CAM table, you will have entries like Z0 by 0 interface. Okay, let me do it according to VLAN so that it will be easier for you to understand. Okay, so Z0 by 0 interface will give the MAC address M1. Okay, and VLAN is 10. Okay, then MAC address M2 will come via Z0 by 2. Okay, VLAN 10. After that, your Z0 by 1 interface, sorry, MAC address, let's say again M1, will come via Z0 by 3 interface, VLAN 20. And MAC address M2 will come via Z0 by 1 interface, VLAN 20. This is how your CAM table will be modified. Now what will happen? So whenever this guy will generate the packet now, so same entries will be there for him. Okay, that he will be trying to use destination MAC address M2. This will come to the switch and it will enter into the VLAN 10. Okay, so switch will say, what is the destination MAC address? M2. So M2 entry do I have in the VLAN 10? Yes, I have in the VLAN 10. What is the port number? Z0 by 2. I will forward it here. Then here we already have created bridge virtual interface. So automatically this traffic will be forwarded here. Okay, and it will enter to the VLAN 20. Again, what is the destination MAC address? M2. So in the VLAN 20, do I have M2 entry? Yes, I have. What is the port number? Z0 by 1. And this will be forwarded here. And then From router, it will be forwarded to the destination. When destination will respond, okay, so the packet that your destination has received is this one. Now for this one, it will generate a response. Okay, so let's say this is the response. Source IP, destination IP. So MAC, destination. Source IP 11.125, destination IP 10.10. Source MAC address will be M2, destination MAC address will be M1. Now this packet will be forwarded from your internet to the router. Router will forward it to the switch. So it will see, okay, entered into the VLAN 20 and destination MAC address is M1. So in VLAN 20, do I have any entry for M1? Yes, I have. The port number is Z0 by 3. Will be forwarded here. Okay. Then through the bridge virtual interface, this will be coming here and it will be entering the switch via Z0 by 2 interface in the VLAN 10. Now switch will check. In the VLAN 10, do I have an entry for M1? So yes, you have an entry for M1 in the VLAN 10 and the port is Z0 by 0 and it will forward here. So this is how the traffic will be forwarded in case of your transparent firewall concept. Okay. And now in the ASA, you can create all the ACLs, policies, everything you can create here. So this interface Z0 by 0, you will give a name to this interface. And let's say you will give here the name as inside. And here you will give the name as outside. Okay. So it will become your inside zone. This will become your outside zone. Okay. Again, all the rules will remain same only. Like, from inside to outside, the traffic will be allowed. Outside to inside, the traffic will not be allowed. Why? Because high security level to low security level, the traffic will be allowed. From low to high, the traffic will not be allowed. So for that reason, you will have to create uh, your ACLs. Okay. All that concept. Is that clear? Theoretically, is it clear? Okay. Now let's go and design the lab and we will perform it practically. Any doubts so far? Anyone? Okay. So we are going with the transparent firewall. So let's take two routers. 1, 2, 3. Okay, let's take three routers. This will be your inside. This will be your internet. This will be your gateway. Then one switch we require. This is the switch. Then we require one AC. Here we can use ASV also, not a problem. This one, let's say this is your internet. This is your gateway. This is your insert. Okay. 0 by 0, 0 by 1, 0 by 2, 0 by 3 connected to the internet. Let's lock the map. Start or nodes. It's inside network 110/24. This is your inside network. On the outside, we will have 11.110/24. This one is going to have 11.125. Here it is going to have 11.110. Here it is going to have 10.110. This is going to have 10.125. And on the BVI, we will assign one IP address. Let's say 10.1.100, just for an example. Okay. Also, the VLANs that we will create. So, okay, interface Z0 by 0 and Z0 by 1. They will belong to VLAN 10, Z0 by 2, and Z0 by 3. Okay, they will belong to VLAN 1. Okay, this is what I'm talking about, switch interfaces. Okay, no need to get confused here. These are what? Switch interfaces. Okay. Then your ASA interfaces. E0 will be your inside interface, and E1 will be your outside interface. Okay. This is what we have to take care of. And this lab is a firewall. Okay. Now let's do the configuration. Let me open Markup. Okay. So by default, the ASA is in router. Okay. We change the firewall mode to transparent. Okay, before that, in the routed mode, there are two firewall modes, routed and transparent. Okay. By default, ASA is in the routed mode. Any routed mode, ASA acts as a history and can be used as an edge device. In transparent mode, ASA is deployed in the L2 mode and it cannot be used as an edge device. Okay. And to change the firewall mode to transparent, you issue there is a command firewall transparent. Okay. And you have to make sure if there is any configuration that is present in your routed mode and later on you want to switch back to routed mode. So whatever is your configuration, always take a backup because this command will blow away all your running configuration. Okay. So this command will blow away your running configuration and even without any prompt. It will not ask you whether you want to save, don't want to save, nothing. It will directly just blow it. Okay. But if you have taken a backup, if you have saved your configuration in the startup configuration, then there is no issue. Okay. It does not touch your startup config. Okay, your startup config, it is not going to touch. No changes happening. Now, let's talk about the configuration. This is what about transparent firewall. Configuration. So first of all, let's see the configuration for your inside R1. Enable configuration terminal. Host name, ASA. Oh, sorry. This is inside R1. Interface is 0x0. IP address 10.1.125.255.255.255.0. No shutdown and V1 route and 1. Okay. This is done. Now for the gateway. Interface is 0x0. IP address is 10.1.1.10. interface V0 by 1, 11.1.1.10. We don't require a route here because both the networks, they are directly connected. So this is done. Now we require the configuration for the outside. That is your internet. Internet. Is 0 by 0 as an IP address 11.1.1.25, and the route will be towards 11.1.1.10. Okay, and let's also enable telnet here. Privilege 50, password 50. Line VPO 034, login local, control input telnet. This should be the full. The configuration for your inside gateway and internet has been done. So first of all, we will just paste this configuration and we will see the normal communication. Then we will see how we can configure your ASA. Okay, and finally we will configure the VLANs and everything will be good to go. Okay, so let's start. Let me take an access of the devices. First of all, ASA. Then let's get the switch. Inside gateway internet. Okay, so first of all, inside say no. Gateway say no. Internet say no. Now here we will paste. Let's copy the configuration for the inside. Done. Oh, this is internet. This is internet. We have to paste in the inside. So this is inside. And then we have gateway configuration. This is gateway. Internet is coming back up again. So right now, what we can do, we can test the communication from inside to gateway. We can say things, 11.10, and I should have the communication. See, so that means from my inside to the gateway, I have the communication. And let me copy. So as of now, from inside to the gateway, I have the communication. Once I copy the internet configuration, till internet will have the communication. And if you check the CAM table in the switch, so this is the first thing I did. So now, so right now only two MAC addresses, one from the Z0 by 0 and second one from the Z0 by 3. Okay, so this is the MAC address for your inside and this is the MAC address for your gateway. Okay, so wait for it. Paste. Okay. Copy it again. Internet configuration copy. Two times. Three times. So interface IPs, IP is correct. IP address is configured. So IP route is also configured. So run five. So line ATY 0 to 4, login local, transport input telnet. This is also done. And what about the 3? Okay. So everything looks good. Now let me test communication from my inside to internet. So if I ping down 11125, I should be able to ping. And you can see right now I have communication. But my traffic, it is not passing through the firewall. You can see right now I have only two MAC addresses. Okay. So what I need to do now, I will change my mode to firewall. Okay, that means I will configure my firewall. Okay, so firewall. So what is the by default mode right now? Router mode. Okay, by default it is in the not routed, somewhere it is routed and somewhere it's okay. But it is the same thing. Okay. You don't need to get confused. This is the okay. So right now it is in the router mode. Now we have to change the mode. So I'll say firewall and transparent. And you see directly without any prompt, it will change the mode. See, now it is in the transparent mode. So in the transparent mode, if I go to any of the interfaces, let's say interface E0, and if I try IP, is there any command? Yes. If I say address, see, unrecognized command. I don't have the IP address command itself. Okay. So now what we have to do, we have to first create the bridge virtual interface. Okay, we have to create what? The BVI. So let's create. So I'll say interface, and in the interface, I will get an option for BVI. That is bridge group virtual interface. So let me say interface BVI, and I can create so many, but right now I will just create number one only. Okay. So I'm saying interface BVI 1. Okay. Now what I'll do is I'll assign an IP address to this interface. I'll say IP address, and the address that we have decided is 100. 10.11, 100. 0. And here you don't need to give no shutdown command because this is a virtual interface. See, even if I give invalid input. Okay. So here I don't need to give it because by default the interface is up. Okay. So I have given it. Now this bridge group I have created. So this bridge group I will have to assign to the interfaces. So what are the interfaces that will be member of this bridge group? My E0 and E1. E0 and E1, they will be the member of this bridge group. Okay. So let's make them the member. I'll go to the interface, okay, and E0. Okay. Then I will say name is, so E0 is my inside interface. Inside automatically security level is 100. And I have to assign the bridge group to it. So I'll say bridge group. And what is the group we have created? The virtual interface number 1. So I'll say bridge group 1. Became part, let's say down. Interface E1 name is outside. Okay. Name is outside. Then here also assign the bridge group 1 and no shutdown. Okay. So I have done it. Now let's see what happens. Let me go to the switch. Check the MAC address table. Okay. So right now you see I have 3 MAC addresses, Z0 by 0, Z0 by 3 and Z0 by 1. Okay. So one more MAC address I got here. Okay. Now, is my communication stopped? No. Why? Because still when my client, when my Z0 by 0 interface, when my inside router 1 is trying to access the internet, it is using the gateway MAC address, and the gateway MAC address entry is there on the Z0 by 3 interface. So due to the entry on the Z0 by 3 interface, it is directly switching there. It is not sending to the ASA. Okay. And when my traffic will start passing through the ASA, first of all, by default, ICMP inspection is not there. So the communication should stop. But still, I'm having the communication. Okay. So now what I'll do, ASA side we have configured. Now all we need to do is what? We need to just go and create the VLANs here. So 2 VLANs we will create here. Okay. We will create 2 VLANs here. One on this side, another one on this side. Okay. These are the 2 VLANs that we are going to create. This side, on the inside, we will use VLAN 10. And on this side, on the outside, we will use VLAN. So that means interface Z0 by 2 and 0 by 3, they will be part of VLAN 20, and Z0 by 0 and 0 by 1, they will be part of VLAN 10. Okay. So let's go and configure the switch. Interface range Z0 by 0 and Z0 by 1. These 2 interfaces which will access VLAN. Yeah. Interface range Z0 by 2, Z0 by 3, which will access VLAN. Now, let me try to have a communication. Do I have the communication? No, right? Why? Because this time the traffic is passing through the firewall. Okay. Now my traffic is going through the firewall, and by default ICMP inspection is not there. What is the traffic by default inspected? What is the traffic that is by default inspected? ICMP? No, ICMP is not inspected by default. TCP UDP, correct. Okay, so that means if I take a telnet access, I should be able to take, and you see, telnet is working, but ICMP is not working. It's good. It's good. See, I'm getting the internet access. Okay. And if I try to ping the same IP address, I will not be able to ping. So that means my traffic is passing through the firewall. Now, if I want to allow ICMP communication, then I can create an ACL or I can allow ICMP inspection. Both the things I can do. Okay. Now, whatever you want to do, all the things you will configure here. Okay. So let's say from outside to inside, from internet, if I try to ping the inside R1, so if I say ping 10.1.1.25, so I'll not be able to ping here. But if I go and to the ASA and if I say access hyphen list, let's say out to in, permit, IP, any to any. That means from any source to any destination. Just right now I'm allowing almost everything. Spelling mistake or what? Configuration. Okay. And then I can apply access group out to in, inbound on the interface outside. Now let me try. I have the communication. See, I created this and I have the communication. So remaining everything you can perform as per what you are performing earlier. To deploy your firewall in the L2 mode, to deploy it as a transparent mode, you just have to create a bridge virtual interface and just assign the membership of the bridge virtual interface to the interfaces. Okay. So what you will do, just in case of ASA, configure terminal. First of all, you will say firewall transfer. Okay. Then interface DVI1, you assign an IP address 10.1.1.100, 255.255.255.0. Then assign the membership to the interfaces. Name is inside. Okay, you will say reach to one, no shutdown. Same configuration for the second interface. E1, name it will be outside bridge group one. And this is you're done on the ASA side. This is all you have to do on the ASA. Then your switch, neighbor, configuration terminal, base range is 0.0, 0.1, switch port, access VLAN pin and same thing for the other side. 30 by 2, 0 by 3, VLAN. This is it. This is your transparent firewall configuration. Okay. Later on, for any kind of filtering and all, you will just create ACLs. Is it clear? Transparent firewall. Okay. Yeah, just not the L3. It cannot behave as a L3, remaining everything it has. Except L3, it will have all the features. Filtering will be done. Okay. So like here also you can have HA concept and all. Those things you can have here. Yeah. Let me see. So this transparent mode is clear. How you can deploy your ASA firewall in a transparent mode. Yes or no? Okay. It's just very simple. All you have to do, create a bridge virtual interface, then assign the membership of the interfaces to the, assign the bridge group membership to the interfaces. That's it. Okay, later on the filtering you will do using the PCLs. Okay, and on the switch, you just have to create VLANs and assign the ports to the VLAN. That's it. Not much of a configuration. Now let's talk about the next concept. Notepad. So your next concept is about MPF. Modular policy. So what is this MPF? Okay, this MPF, it is also known as deep packet inspection. Okay. Also known as deep packet inspection. With the help of MPF, your ASA is able to perform inspection. Okay. So kind of you can say this MPF is something that allows your firewall to check the layer 7 characteristics. Although your ASA is a layer 3, layer 4 based firewall, can do the filtering based on layer 3, layer 4 only. But with MPF, for certain protocols, it can check layer 7 characteristics. Okay. So like how? So first of all, understand. Let me Okay. Let's talk about your FTP protocol. Everybody is aware about FTP? Yes or no? Okay, good. So let's say you have this one PC and this side we have one server. Okay. So this is PC, this is server. Consider this PC has an IP address 10.1.1.1 and server has an IP address 10.1.1.10, just for an example, and they are connected. Okay. And here FTP is enabled. This is, let's say, FTP server. Okay. So when client will initiate a request for the server, okay, so what is the port number it is going to use? Let's say if we talk about the packet, so there will be source IP, destination IP, source port, and destination port. These things will be there. So what will be the source IP when PC will generate a packet to access the FTP? The source IP will be, yes guys, what will be the source IP? No response?
10.1.
10.1. What will be the destination IP?
10.10.
Okay, good. What will be the source port?
Say random.
Okay, so let's say 16347, just for an example. Destination port number?
20.
20. Okay. 20 or 21? What are the ports used by FTP?
20 and 21.
20 and 21. So when your PC will generate the request, it will use the destination as 20 or 21?
20.
Why 20? Why the port number 20? And why port number?
It's a transfer the data, like requesting.
So without connection, can they transfer data?
No.
No, right? And which port is used for the connection control?
21.
21. So here destination port will be 21. So that means request will go from here to here. From 10.1.1.1 port number 16347 to 10.1.1.10 port number 21. Now what will happen? Who will start the data transfer? Client needs the data, right? See, what is the behavior of FTP? Understand here that whenever a client generates a request, okay, so client will generate a request for the port number 21. Then server will use port number 20 to send the data. Okay. So when server will start sending the information, server will say 10.1.1.1, this is the source, sorry, 10.1.1.10, port number 20. And then server will send this data to the client on a port number that the client has opened for the data transfer. Okay. So client, let's say client has opened the port number 24367, something like this. Okay. So this is how the transfer will be. Okay. Understand again? When client will generate the request, client will use a random port number, and for the server, it will use 21 as a destination. So from this random port number, the request will be sent to port number 21. Then when server will start data transfer, server will use source port number 20, and it will send to a port number that the client has already opened for the data transfer. Okay. Now, in normal case, this is fine. They will start the data transfer and the data transfer will be complete. But if you have a ASA in between, now understand the case. When you have a ASA in between, this is your ASA. Okay. This is your client. This is your server. PC. This is your FTP server. Okay. Having IP address 10.1.1.1. Having IP address 10.1.1.10. Okay. And this is your ASA. This is your inside zone. This is your outside zone. Okay. Now what will happen? When PC wants to access the FTP server, okay, let's consider this IP address as a different, because in ASA between, let's say this is 11.1.1.10, for example. Okay. Now, your client will try to access the data, access the FTP server. So it will send the information from here to here. Okay. Now again, like I said, it will use the source port number 10.1.1.1 and let's say port number 24333. This is some random port number it has used, and destination will be, it will be using 11.1.1.10 and port number 21. So what your ASA will do when this traffic will come to the ASA will make a connection entry in the connection table. So how the entry it will make that, okay, a connection has been made to 11.1.1.10 port number 21, which is available on the outside from inside, and who was the one who was responsible for this connection? 10.1.1.2.4.3.3.3. Like this, it will make a connection, and it will say like this is a TCP based connection. This kind of entry it will make, so that when the response will come back from this IP and port number, your ASA can allow the traffic. And this one already from inside to outside your ASA allowed, because it was going from a high security level to lower security level. So your ASA allowed it, fine. And if the response is coming from the same IP and port, your ASA will allow it. But when let's consider, when this FTP server will initiate a connection, okay, when this FTP server will initiate a connection on the port number 20, from the port number 20. So it will use source as 11.1.1.10, port number 20, okay, and it will try to access a port number, okay, it will try to access a port number that is opened by the client. So how server will come to know that what is the port number the client has opened for FTP data transfer? So in this packet, when the client is trying to access the server using port number 21, the one that is for the connection control, in this packet itself, the client will mention that, okay, I have opened, let's say 25666, that I am opening this port for the data transfer. So when server will see this information, server will send the traffic to 10.1.1.1 and port number 25666. Because server can read up till layer 7, right? But ASA cannot read. So if ASA cannot read, that means this entry will not be there. Connection entry will not be there. And the traffic is coming from outside to inside. Will it be allowed? Going from lower security level to high security level? No, it will not be allowed. Okay. And this is where your MPF comes in picture. Your MPF, or you can say your deep packet inspection. Okay. So your MPF it gives a capability to your ASA firewall to look into the packet. Okay. So with the help of MPF, what your ASA will do, ASA will look into the connection when this PC1 is trying to access the server. So it will look at that particular packet and will see that, okay, the client will be opening this packet. The client will be opening this port for the data transfer. Okay. So automatically your ASA will make an entry that, okay, TCP from outside, when the server will respond using port number 20, the inside 10.1.1.1 has opened the port number 25666. ASA will automatically, just by looking at the packet information, okay, and performing the deep packet inspection for this protocol, ASA will automatically open it and check this information and will make this entry. Now already the connection entry is there. That means ASA will allow this traffic. Okay, this traffic will forward from here to here. Okay, this is how your MPF plays important role. Another protocol, let me give you an example. Like, I believe if you guys are aware about the eSMTP protocol or SMTP protocol, if you guys are aware. So in SMTP protocol, what happens? Total 20 to 25 messages are there, around 20 to 25 messages are there, but not all the messages are used for mail purpose only. There are certain messages that will give information about the server, about the mail server, about the usernames, okay, about the mail addresses. These kind of information are given by multiple packets. So what your ASA does with the help of MPF, that it will allow only that 5 to 6 messages that are needed for mail to transfer. Okay, other messages that are responsible for giving out information, those it will not allow. Okay, so again, how your ASA can make a decision that, okay, this is the message that is having this command, and this is the message that is having a command that is for the exchanging mail, and another message that is having a command for revealing the information. Okay, how your ASA will be able to make the decision? Again, ASA will have to perform what? Deep packet inspection. And how your ASA will be able to perform the deep packet inspection? With the help of your modular policy framework. Okay, so the use of MPF is just what? That it allows your firewall to check the layer 7 characteristics. Okay, and not about all the protocols, only specific protocols. Is that clear? So we cannot say that, okay, your ASA can perform layer 7 filtering. No, here it is not filtering. It is just checking the layer 7 characteristics. Okay, so do not confuse it with the layer 7 filtering. It is just inspecting the packet so that for a particular protocol, it can take an action accordingly. Okay, because if your ASA is not able to perform, let's say, deep packet inspection, then you will, if you are using ASA, you will never be able to, have the FTP communication. Okay, so do not confuse it with the filtering. This is not layer 7 filtering. This is deep packet inspection. That means just checking the characteristics for a specific protocol. Is that clear? Clear, right? Okay. Now, let's see about the MPF. So this is also known as deep packet inspection. It allows the firewall the ability to check layer 7 characteristics. Okay. So there are a bunch of protocols that are checked by default and specific actions taken. So like I gave you example, right? ESMTP, FTP. So there are the protocols for which that are by default checked and for which a specific action is taken. And like I said, this is not for all the protocols. The checks are dependent, okay? Or you can say the checks and actions are dependent on the protocol. So it will depend on the protocol. According to protocol, it will make a decision. Okay. Now, for MPF, there is a three-step configuration. Okay. Your deep packet inspection, on the ASA firewall is implemented by using three-step configuration. There is a three-step configuration, which is called modular policy framework. That three-step configuration is what? Your modular policy framework or your MPF. Okay. In MPF, a protocol is classified in a class map. Okay, there is something called as class map in which the protocol is classified. Then to define action, we use a policy map. Okay. An action is specified for the classified protocol in a policy map. Okay. And then we apply this policy map to the firewall. The policy map is applied to the firewall. Okay. So there is a default class map already available. The default class map is called inspection default. Okay, this is a default. Everything in the small inspection default. This is the default class name. And what it is going to do, definitely it is going to check number of protocols. It is going to classify a number of protocols. Okay. And the default class map is called in the default policy map. Okay. The default policy map is global policy. Okay, this is the name. These are the names. And this global policy is applied globally, which affects all traffic. Okay. Now let me show you inside the firewall that what is this three-step configuration. Okay. So let me open this here. So first of all, let me show you class map. So I'll say show running class map. So if you see my default class map I have is the inspection default. Okay. And in this class map, I have a classified protocol and it is saying that match, and what I'm trying to match, default inspection traffic. Okay. So if I check it, okay, let me go to this class map and let me see that what are the protocols classified in it. Okay. And if I say match, and what it is matching, the default inspection traffic. Okay. If I give question mark, see here, I have default inspection traffic, and these are the protocols that are matched under this. Okay. So you can see I have FTP is here, HTTP is here. Okay. Then you will find SMTP is here. Okay. ICMP is also there. Okay. You see, ICMP is also there. So that means ICMP is also classified by default. But is ICMP inspected by default? Is it inspected? No, it is not inspected. Why? Because in a class map, you just classify a protocol. The action that you take it in a policy map. Okay. And if we see, the default policy map is what? Global policy. Okay. So let's go and check this policy map once. Okay. Let's go and check it. So I'll say show running policy map, and I'm looking for my global policy. Okay. So in the policy map, I have called my class map where I have classified different protocols. But out of all those protocols, what are the protocols I'm taking the inspection action? Only these protocols. So you see here, I have ESMTP, I have FTP. So these are the protocols for which I have defined an action. Is there any action defined for ICMP? Is it saying that I'm inspecting the ICMP protocol? No, right? So this is the reason that by default ICMP inspection is not there, because in the global policy, in my policy map where I have to define the action, so there is no action defined for my ICMP protocol. ICMP protocol is classified, but action is not defined. So if action is not defined, my firewall will not take an action and the default action would be denied. That means no inspection. Okay. Then how do I inspect it? Okay. So how do you inspect? You just go to the policy map and you say inspect ICMP. So let's go to the policy map. Policy map, global policy. Then I will use the class that I have used there. This is my class. Okay. Now I have to take an action. So let me take an action, inspect ICMP. I have taken the ICMP inspection. Now let me say show running policy map. And I'm looking for my global policy. Do you see the ICMP inspection? Now ICMP inspection is enabled. So that means I should be able to ping from inside to outside. So if I say ping 11.1.1.25, I'm able to ping. Okay. And if I do not inspect, then I will not be allowed. But I think I have given one ACL here. So running. Let me see here, configure access list. So running access list. See, I don't have any access list applied. And now if I try to ping, still I'm able to ping. Why? Because my ICMP inspection is there. I have allowed ICMP inspection. And if I do not allow this ICMP inspection, see here what will happen. Okay. If I say no inspect ICMP. Okay. Now I have removed the ICMP inspection. ICMP is no more inspected now. And if I go and check here, the communication, I don't have the communication. Is that clear? Yes or no? So what is the difference from fix-up protocol ICMP? See, fix-up protocol ICMP, the fix-up command, it is coming from the fix firewall. It is still present. Okay. So what your fix-up protocol ICMP does? See here. This is right now there is no ICMP inspection. Eventually, fix-up protocol ICMP will do the same thing. Okay, if you read the log, okay, now you read the log. If I say fix-up protocol ICMP, what it is basically doing, what my firewall is doing, converting this to MPF commands. Okay, this is just converting this to MPF. So eventually in the backend, it is doing the same thing, that policy map global policy, class inspection default, and inspect ICMP. And that is the reason that you will see here, now your ICMP inspection is there. Okay, this command was present in the fixed firewall, but it is now still there in your ASA. But it does what? It does just conversion to the MPF only. That means now it is not being applied. This command is not being applied. It is just getting converted to the MPF. You know, like kind of you can say, like when you right now in Windows 10 or 11, if you try to open Internet Explorer, what happens? Automatically getting redirected to Edge. Yes or no? So kind of the same thing here. That okay, the option is given Internet Explorer, but you are getting redirected to the Edge. Same like that. This command is there. This command is there, but eventually it is getting converted to what? Your MPF only. So this is, as of now, you can consider, okay, this is a shortcut for you to enable ICMP inspection. Okay, but the correct way will be this. Is it clear? Okay, so always remember, in the class map, protocols are classified, the action will be defined in the policy map. Okay, so if in the policy map action is defined, action will be taken, otherwise no action is taken by default. That means no inspection at all. And if there is no inspection, the traffic will not be allowed. The return traffic will not be allowed. Okay, so this is your MPF concept. Yeah. Now we just have left with one concept, that is your IOS zone-based firewall. Okay, so tomorrow we'll see that how you can convert your router as a firewall. Okay, how you can convert your router into a zone-based firewall. Okay, so in a router itself, we will be creating inside outside DMZ zones, and we will be creating it as a firewall. Is that clear? So that is the last topic, and tomorrow we'll finish your ASA. So any doubts you have in today's part, transparent firewall, MPF? Okay, great. All right then, I'll see you guys tomorrow. If you face any doubt, any problem, you can always drop in the group. And yesterday I forgot to upload the documents. I'll do it today. Okay, after this session. All right, guys, then I'll see you tomorrow. Have a good day. Okay, guys.